Okay, this video is about standard enthalpy changes. When we compare different enthalpy changes, we like to compare them by the type of enthalpy change they are, but also we want to be able to compare them, and to be able to do that, we have to know that they're done in similar conditions, or the same conditions, otherwise it's not a fair comparison. So, to show what kind of conditions an enthalpy change has gone through, we have this symbol here. This symbol is a circle with a line for it, means standard conditions. Okay, so delta H, enthalpy change, done in standard conditions. And we get different types of delta H. We signify that with a little letter here on different examples. Okay, so what are the standard conditions? The pressure has to be 100 kilopascals, which is 1 atmosphere. Temperature, 298 Kelvin, which is 25 degrees centigrade. And if it's an aqueous solution, which not all reactions are, they have to be 1 mole per dm cubed. If those conditions are met, then all the reactants and products will be in their standard states, which is the physical states under those conditions. So for example, water will be a liquid with that pressure and that temperature. Okay, so one type is the standard enthalpy change of combustion. Okay, so we've got that delta H and the standard condition sign up here, and then we've got a C, show it's the enthalpy of combustion. So this definition you need to know, the enthalpy change that takes place. So always start it off that way, to say it is an enthalpy change, not to start the sentence here, when, when what? Enthalpy change that takes place when 1 mole of a substance reacts completely with oxygen. So it's always got to be 1 mole of a substance, and it's always got to be completely with oxygen, because it's never incomplete combustion, it's complete combustion. Under standard conditions, all reactants and products be in their standard states. That bit there's strapped on the end to show that it's done in standard conditions. Okay, so this equation matches up with this definition because we've got 1 mole of ethane reacting. Okay, so it matches up there. 1 mole of substance reacts completely. There's enough oxygen here to produce carbon dioxide and water as the products. There's no carbon monoxide or carbon soot, so that's complete combustion. Enthalpy of combustion of this reaction minus 1,560 kilojoules per mole. So that number of kilojoules released for every mole of ethane that's combusted. Okay, so it could be that rather than burning 1 mole, you burn 2 moles, in which case this would be the equation. 2 moles of ethane, 7 moles of oxygen. Now this is no longer the enthalpy of combustion because it's not meeting the definition of when 1 mole of a substance completely reacts with oxygen. It's 2 moles, so now it's enthalpy of a reaction, standard enthalpy of a reaction. Okay, but we can quite easily work out the energy change because here we combusted 1 mole, now we're combusting 2 moles, so we times the energy change by 2. Let's get this figure here. Okay, so what is the enthalpy of a reaction? Again, another definition you need to know. The enthalpy change that accompanies a reaction in the molar quantities expressed in a chemical equation under standard conditions, all reactants and products being in their standard states. So what it basically means is it's the energy change for that particular reaction, the way you've balanced it there. Okay, for this reaction, in these quantities, 2 moles of that reacting with 7 moles of that will give you this amount of energy. Okay? Alright. Standard enthalpy change of formation. So another definition that you need to know is the enthalpy change that takes place when 1 mole of a compound is formed from its constituent elements in their standard states under standard conditions. So here it's when 1 mole is formed, not when 1 mole reacts, it's when 1 mole forms. So here we've got 1 mole of water forming from 1 mole of hydrogen and half a mole of oxygen. Okay. Again, delta HF, so the little F signifies that it's a formation reaction. That sign there, standard conditions. So if we formed 2 moles of water, the reaction will balance like this, but this now does not match this definition because we're forming 2 moles, not 1 mole. But again, we can work out the enthalpy change. The enthalpy change of reaction could be 2 times this value here.